Good afternoon, everyone. Let's begin our lesson. So, welcome. Thank you. So cute. I love these words because I love laughing, right? Maybe my attitude can release your pressure, right? Yeah. Yes. Sometimes we will feel nervous. Sometimes we'll feel a little bit of pressure and stress, right? So I like to contact with a friend that they have the same like opinions and the same attitude with me. Yeah, maybe I will feel better when I feeling nervous. Okay. Thank you very much for attending my consent meetings. Okay. I'm your teachers, but at the same time, I'm your friend. Okay. Yeah. So this is the 11th week of this semester. So we arranged that the schedule for the next time to organize our teaching, like a teaching's plan, right? So please check that our WeChat. We have scheduled the sequence of next week. Let's begin your presentation, right? Yeah. Do you remember? Please type 1 if you remembered and know that your sequence. Thank you, Anna. Oh, yes, Chris. Thank you. Thank you, Betty. Nijist, thank you very much. You have a good memory. Okay. So today, I changed my teaching schedule because I think we should to know some like a different topic. Yeah, different topic. Maybe we should not based on that is pure technology. You know that depend on technologies, we can improve that is some society, the life level and that our feelings, our lifestyle feelings. Yes, it's true. But you know that sometimes the important things is the status of the humans. And when we're living in that IoT society, what we're feeling and we will to what we will to do, and sometimes we will get more and more advertisement, right? Scientific and socialist, and sometimes is like technical advertisement. So we should to organize this information together. I think in one aspect, these informations can help us to choose our career. Yeah, in the futures, it's very important. So today, I set 2 topics and to share with you. The first The first is like a culture, and I check that is the culture and the economy. Culture and economy. And second, I will play a video, and this video comes from that uh, MIT that about the healthcare. I think that this professor tell us more and furtherly about that how to use machine learning to deal with some data in healthcare. In healthcare, but you know that my major only based on computer science, right? But when we know about that is applications and to furtherly to get make sense, I think we should to uh, get more topic, professional topic about these areas. Okay. Yeah. Let's begin our first issues. I will share my desktop. Please wait a moment. I shall. Yes. Okay. Where's my PowerPoint? Is here. Yes. Okay. Yeah. Okay. Yeah. Can you see this slide?
It's closer.
Thank you.
It's closer.
Thank you very much for your feedback. Okay. What's the culture? I only want to introduce to that a famous actor. Like I don't know whether you know about him, about her. That is Li Ziqi. Yeah, I like this blogger, the famous blogger, and she always to share that is a traditional Chinese food, like come from nature, nature, and you can know about from her videos to know about the Chinese cultures. Yeah, I like her videos. So on April, that is 29, maybe the year before, maybe 2000, I think 2020. Okay, a well-known blogger that he have 10 million fans on YouTube. Yeah, you can check YouTube, and the total of 1.35 billion viewers. Why? What's the topic? About that, like a nature sense, like that is for culture about Chinese, what how do they make food and how use that nature materials, right? Yeah, and to do many delicious food. Yeah, I introduced him that his life is very ordinary but full of expectations. Yeah, from the garden life, right? So I hope you can become people who love life and find your own peace in the world. Okay, this is about that is from online that we can get the videos and to get to know about that the life. Yeah, so this is one aspect for the modern society society we can familiar with the lifestyle and to know about that the different cultures. Okay, so further, I think I only wanted to open a view for you about our country, our country, our culture and economy. I think um, some of you, some students have been in China and maybe lived here for a long time, I think you love China, right? And China, like its food, like Nanjing. Yeah, so it's my pleasure. So maybe some of you that only stayed at your hometown, at in your countries. I hope that in the future, I think that is COVID-19 disease can disappear, and all of you can come back to our campus. Yeah, to our campus. So we can from today's topic, I wanted to introduce that in China, how to develop that IoT technologies in applications and in their life. Okay, let's see. This is green retail windows, such as Jingdong. That's Jingdong. This is a famous company, delivery company, right? Its examples is famous. But in these areas, worker can busy packing the goods and like at an commercial industrial zoo in Lianyungang. Lianyungang is a city in the southwest of China. This is south of China is have I think it's famous and Jiangsu province. This is an example for that in this factory, in this the deliver factories that workers working, right? But in the area of big data, right? So cloud computing and Internet of Things, information data will see explosive growth in these areas because you know that in deliver areas that the consumer and that deliver and the company and industry and that is shopping mall that they connect together. Yes, so sometimes they will share the informations and sometimes will process the data in the first time, right? Okay, this is for, and this is the scenarios for the visitor tied to Meituan bike. Meituan, this is a website in China that is online I say the shopping service, and sometimes you can easily to make that is work out online to and the delivers can quickly send that your orders for you. That this is a bike. For this bike is very cheaper, can rent. So a rentable bicycle, which is a part of the bike sharing systems. So in China, that much many cities that have this bike sharing systems, such as Nanjing, right? And during the China International Fair for Trade and Service in Beijing, that in these fields provided that is a large amount of file on tag guide that is made for that is monopolistic that is behaviors because as a citizen in urban some cities in rural that we can find this rentable bicycle. But you know that based on IoT, we should provide that is GPS, right, to detect that in bicycle locations. And sometimes we should to calculate that fee. Maybe, no, I want to maybe that the rent fee is very cheaper. And sometimes limited in 1 hours, you should not pay. It's free if you have a high points in Meituan this desktop. So organized that is a chain, a traffic chain, like to provide convenience for that is citizens. This is for the rental bike. And this is a virtual reality and augmented reality industries. In these areas, let's see, to the report released by Global Market Consultancy International Data Corporations, a total of that 2.2 million, that is AR and VR. All this is for like a triple dimension, the visual, right? Two headsets were shipped global during the second quarters, and the skyrocketing. So that is to the same period last time. That means that these technologies can be used increasing, right? So attendance experience VR, that is motorcycling. Yeah, and well, at the 2021, the World Conference of VR Industries that to give that the scenarios, these examples, applications in Nanchang. Nanchang, this is city in China, in like is the north of China, that is for industrial cities, and in Jiangxi province. Okay, this is exhibitions in these areas for this VR in the motorcycling. Oh, this is and by the way, all of these informations I I abstract from the Daily China Daily, the newspaper. Okay, like in this news, a person worked past that is HQ of recently fixed by Alibaba. Alibaba, that is a famous company that provide the consumer website, and to products purchased per products, and like you can orders and like to purchase something on Alibaba, right? And in Hangzhou, this is border company of like in Zhejiang province. The Zhejiang is the southwest, that is cities, like is a person's. In that is in this expectations, latest data from China Academy of Information and Communication Technologies showed that a digital platforms with a valuation of over 1 billion, right? 1 billion each hit 197 in China. Wow, that is have a range areas to provide that service based on website, and sometimes to improve that economy in China, right? Yeah, okay. This is second Alibaba. And here, this is for industrial areas. In September 2021, that is Changchun. Changchun is a city, the famous city is in the north of China. That is for industrial, that is these areas. And international automobile city, that is had 80 major projects in cities, project building borders. These borders can make the automobile. Place from like a 35, not 35, 15 years, or lasted 15 years, like a 30 plane. These planes is focused on the key projects and research and development. in this, like is automobile cities, industrial this chain, that chain. Okay, here, let's say this is China about in information security. Yeah, and China data security sector to standard growth with an implementation of the data security law. This means now that the government have provided a series of the security law to protect the data. Okay, such as privacy, such as like authority to use that our software, some app, we should to have the right to get the permissions to like access, get the data, and sometimes we can use this app, but based on that is the law, right? And with the rapid development of emerging technologies, such as in communications, such like 5 generations, 4 generations, use artificial intelligence. Such artificial intelligence give us a windows. Yes, we can use like is different analysis method technologies to dig mining, right? To dig mining, no, to mining data, or to mine data and to dig that is informations, and sometimes will give us the professional like is prediction or prediction. And so cloud computing can provide us that is desktop to install, store the data, and sometimes give us the scientific and is optimal infrastructure to organize that is hardware and software faced the different applications, right? Yeah, and the Internet of Things. Yeah, this is a pervasive area, right? And blockchain. Yeah, blockchain. Blockchain means that we can use these technologies to give us that is safety and is to help us share that is distance, share that informations based on that is unique law. I always expressed these ideas. This means we should to use the blockchain to give you ID and to maybe you can have a right to access the data, right? The blockchain and the big data, right? Big data and China's digital industries booming. Yeah, the booming. This is recently that is a trend for Chinese economy based on IoT, based on that is society, right? Okay. More and more enterprises have attached greater importance to data security and strengthen regulations. Regulations. Okay, we should obey the standards. So maybe this obey must be guided by the government. And the next, the revenue of China's cyber security industrials were expected to exceed. This means more and more enterprises will pay extra that is fund, that is wages in these areas for security areas. Okay, and data security is more important than ever before. I agree. I agree. Yes. So, above this slide introduce, you can think about issues that maybe in the future you will find some company, you'll find a job, right? Find job, and maybe you will choose the correct, the reasonable that you like job, your positions in the world. But what's your major? What's interesting? What that is popular? That is job areas that can suitable for you. Yeah, and I suggest you don't only account for that is wages, that is the paid that the company will give you. The more important is you should account for that the future. This company's objective, developed objective, and maybe that the opportunity that this company can provide you in the future opportunities. And sometimes that maybe this is a small company, right? But that your boss and that your team members have stand on high levels, have a view that about how to improve their companies based on that is modern society demands, and sometimes that is latest and modest, that is the technologies. So I suggest you can choose these companies. Yeah, it's good. Okay. Our slide is simply introduced some aspect of that is development economy that in China. So I think that you can read more more newspapers in Chinese newspapers to further know about that our country's development. Yes. Okay. Next, I will open some videos, and the next lesson I will play that is MIT, the videos. Okay, let's see. Here. Okay. I check my notes here. That is because here the future industry IoT. Sorry. Okay, can you see these videos and can hear that this the voice, right?
Hi, I'm Philip, and today we will talk about the future of industrial IoT. For that, I have two thought leaders with me from automation and cloud. Hi, Rainer. Hi, Ralf. So, where are we today, Ralf, regarding cloud computing, and what trends do you see in the future?
So it's now 4 years that we actually have MindSphere, the open IoT operating system in the cloud from Siemens. And what we see here at the SPS Fair is actually an amazing growth in applications and solutions for MindSphere IoT. And actually what we also see here, that it arrives now on the shop floor with all the solutions and applications which we have. And now with what we announced here today with Rainer, we add another member to that family, which is Industrial Edge.
So what are the benefits from industrial edge computing?
Well, first of all, congratulations for 4 years. I don't have 4 years yet. We just launched into the market today. But I think Industrial Edge is a very good link between cloud and control. And what we enable with Industrial Edge is we bring really IT technology down to the shop floor. This enables deployment of application, update of application, enables new business model for our customers, but also brings technology like artificial intelligence, inference of artificial intelligence, data analytics down to the shop floor.
This sounds already great. How do you guys think, how will this look like together in some years or already today?
So what we will see is a lot more analytical applications, streaming analytics, where you need high power, compute power, because you have high frequency data coming out of the shop floor. And then it makes sense to have that compute power actually utilized in the Industrial Edge. And then you have hybrid use cases, which actually you can decide whether you want to do something in the cloud or on the edge. So it gives you more flexibility and therefore way more use cases which can be addressed.
Okay, but there's even more?
No, I can add on. The future is going to be hybrid. So we have a lot of functionality where we do on the shop floor, and we have a lot of topics which absolutely make sense in the cloud. And the customer can decide, or the application decides where it makes sense to deploy this application. And I also think that, really scaling this ecosystem, it's very important having the right devices, right device builders, but also the right apps there. And I invite everybody to really join this ecosystem.
Thank you, Ralf. Thank you, Rainer. If now you want to have more information, visit us online.
Siemens, ingenuity for life.
Okay, this is for Siemens that for the future that we use that intelligent devices used in that aging computing. Organized that is this infrastructure in architecture, right? So next, Google about IoT. Okay, I want to know whether you can hear these videos clearly. If you can, please type 9.
Data. It's being created all the time, from devices, applications, and their users. Because it's digital, it's measurable. But what about information offline, in the physical world? There's actionable offline data just waiting to be discovered. And with devices that can capture, convert, and send the newly discovered data, businesses in any industry can start measuring their operations in real time to anticipate events proactively and to spot issues before they become problems. Processing this data would be easy for a few devices, but what about hundreds, thousands, or even millions? Google Cloud Platform offers powerful tools to capture massive volumes of data distributed around the world, along with an easy way to process the data, whether it's streaming in real time or tucked away in your logs. Query instantly into what's happening in any part of your business with easy-to-use big data tools and zero infrastructure management. So no matter what your business is, you can analyze performance in all the places that matter. This is the Internet of Things. Get started today and see how Google Cloud Platform can extend your businesses into a connected world.
Yes, you can check on Google Platform, Big Data Platform, all right? Yes. Next about that is for IBM. Their view about IoT. creative conversation, customer conversations, how to record data, how to count that is end-to-end and is only different models, unstructured, semi-structured, structured. This different type of data, iterative, flexible, scalable, and composable, reliable. Meaningful, productive. Okay, this is an IBM opinions about that IoT. This opinion provided maybe 5 years ago, but we can see from these videos that we should auto identified that the data, and sometimes at the same time we should that is get the meanings of the data. So come back. Let's recall we've studied. In the first I think 3 classes, I introduced the architecture of IoT, right? So the more important, not only based on that is the first level, like is hardware, but the middle layer, like communication and processing, data processing, process data is more important. We use internet and local network and Wi-Fi, Bluetooth, and microwave. All of these sensors, devices to integrate together. But we based on that is the particle, communication particle. But you know that the data should to transmit through the different particle network. So we should account for use that is the router and a gateway and access point. Yes, can help us to transmit the data and to combine, give that is Unicode, transmit that our data to the internet. We get the data and use the service to calculate, to process the data. It's okay. But now, if we stand on that is the application layer, we should account for that is a human machine, that interactions, how to give these interactions between that is human and the machines, right? And we should develop that interface to provide that the human to get that is the data and to get that we need information can conveniently, that is easily to get the data. But on the other hand, that we should use that is like RBS, with blockchain to provide us the security, the safety, and schema. And we should to give us that the service based on our customer and our locations, right? Yeah. This is about that is different. A layer. If we are engineer, we should to face so many aspects, right? Okay, let's see. Let's see. Another. We will have a rest. Okay.
By 2025, most electronics will contain some level of smart technology, enabling them to connect and share data. This interconnection. By 2025, most electronics will contain some level of smart technology, enabling them to connect and share data. This interconnection of devices is known as the Internet of Things. That is ready to meet the demands of a connected digital world. An enormous amount of data is being generated by users using smart devices. Corporations analyze this data to improve their products and create business value. Well, let's think about the logic behind this. Users generate valuable data, but corporations get all the benefits. After using IoT Chain, users will be surprised to find out that they will be paid a portion of the sold user data through ITC because they do create value, and they remain in control of the data they generate. The decentralized nature of our network ensures your information remains secure, while at the same time, you can choose to provide your data to third parties who want it. Businesses can analyze the massive amounts of data, but users are the ones who are always in control of what to share. Using a hybrid DAG approach of blockchain, we are able to create a decentralized IoT network, which is expected to handle up to 100,000 transactions per second. ITC combines asymmetric cryptography and a distributed structure to store information without a data center. It does not only solve equipment security problems, but also protects device and user data, sovereignty, and privacy. The IoT chain network requires a predictable and cheap fee for value transactions for security purposes. Our chip-based solution is easily integrated by device manufacturers, and chips can be updated easily without replacement. Also, ITC's hybrid architecture supports smart contracts. There are many applications for IoT chain in real life. Smart devices, sharing economics, manufacturing, transportation, healthcare, renewable energy, public safety. In the IoT chain ecosystem, the ITC token acts as a carrier of value and ownership, exchanged among intelligent devices. The user can purchase ITC tokens to buy the right to use the smart device for a while. For example, a car. There is a fixed supply of IoT chain tokens. As more devices join the network, the demand for ITC tokens grows as people need tokens to facilitate transactions. Companies that wish to test and use the IoT chain network will need to purchase ITC tokens over the counter, which adds to the demand as well. Why are transactions so slow now? Because to get a transaction confirmed in the whole network, you need to wait for a block to be created. It is 10 minutes for Bitcoin and about 15 seconds for Ethereum. You always have to wait until a block is created, and then your transaction can be confirmed. The reason why ITC is using a hybrid DAG architecture is because it is much more efficient than a pure blockchain network. The DAG data structure represents the next generation of distributed ledger technology, often called Blockchain 3.0. It does not only resolve the concentration of mining, but it also greatly increases the capacity of the network and lowers transaction fees.
IoT Chain's progress in using blockchain and blockless DAG technology gave the opportunity to receive the Blockchain Excellence Award at the 2018 World Economic Forum. Internet of Things is the next big mainstream industry after the mobile internet. We are confident that IoT Chain will become the go-to platform for such devices by providing manufacturers with simple access to a powerful IoT ecosystem.
Okay, and these videos introduce that is use the IoT chain. This chain means if we use in IoT in specific areas such as industrial, agriculture, and like is healthcare, and we should account for not only the hardware choices and the data process and the energy savings, right? And this aspect should be cooperation together. Yeah. So this need more and more engineers to cooperate together. And sometimes when you maybe one day you will enter into a company, IoT company, you will find that a different group, technical group, will always make discussions together to exchange their ideas about one project, to share their opinions and their I think that is a creative ideas, right? Okay, that's it. Let's continue next lessons to hear to watch these videos, and let's have a rest for 10 minutes, right? Please come back at 40. Okay, have a rest. Okay. Hello, everyone. Have you come back? Yes, 老师. Thank you.
Yes, 老师.
Okay. So these lessons, I will open that videos about IBM. How to use that is machine learning to process the data from that medicine areas. I will choose some segment to you, and please to watch these videos. I think these videos will give you some. I think that is tips. The tips. Okay. Let's share. Okay, I check with my videos here. Here. Okay, that is a here.
So welcome to Spring 2019 Machine Learning for Healthcare. My name is David Sontag. I'm a professor in computer science. Also, I'm in the Institute for Medical Engineering and Science. My co-instructor today will be Pete Solvitz, who I'll introduce more towards the end of today's lecture, along with the rest of the course staff. So the problem is that healthcare in the United States costs too much. Currently, we're spending $3 trillion a year, and we're not even necessarily doing a very good job. Patients who have chronic disease often find that these chronic diseases are diagnosed late. They're often not managed well. And that happens even in a country with some of the world's best clinicians. Moreover, medical errors are happening all of the time. Errors that, if caught, would have prevented needless deaths, needless worsening of disease, and more. And healthcare impacts all of us. So I imagine that almost everyone here in this room have had a family member, a loved one, a dear friend, or even themselves suffer from a health condition which impacts your quality of life, which has affected your work, your studies, and possibly has led to a needless death. And so the question that we're asking in this course today is, how can we use machine learning and artificial intelligence as one piece of a bigger puzzle to try to transform healthcare? So all of us have some personal stories. I myself have personal stories that have led me to be interested in this area. My grandfather, who had Alzheimer's disease, was diagnosed quite late in his Alzheimer's disease. There aren't good treatments today for Alzheimer's, and so it's not that I would have expected the outcome to be different. But had he been diagnosed earlier, our family would have recognized that many of the erratic things that he was doing towards the later years of his life were due to this disease and not due to some other reason. My mother, who had multiple myeloma, blood cancer, who was diagnosed 4 years ago, or 5 years ago now, never started treatment for her cancer before she died 2 years ago, or 1 year. Now, why did she die? Well, it was believed that her cancer was still in its very early stages. Her blood markers that were used to track the progress of the cancer put her in a low-risk category. She didn't yet have complications, visible complications of the disease that would, according to today's standard guidelines, require treatment to be initiated. And as a result, the belief was the best strategy was to wait and see. But unbeknownst to her and to my family, her blood cancer, which was caused by light chains which were accumulating, ended up leading to organ damage. In this case, the light chains were accumulating in her heart, and she died of heart failure. Had we recognized that her disease was further along, she might have initiated treatment. And there are now over 20 treatments for multiple myeloma, which are believed to have lengthening effect. I can give you 4 or 5 other stories from my own personal family and my friends where similar things have happened, and I have no doubt that all of you have too as well. So what can we do about it is the question that we want to try to understand in today's course. And don't get me wrong, machine learning, artificial intelligence will only be one piece of the puzzle. There's so many other systematic changes that we're going to have to make into our healthcare system. But let's try to understand what those AI elements might be. So we'll start in today's lecture by giving a bit of a background on artificial intelligence and machine learning healthcare. And I'll tell you why I think the time is right now in 2019 to really start to make a big dent at this problem. Then I'll give you a few examples of how machine learning is likely to transform healthcare over the next decade. Of course, we're just guessing, but this is really guided by the latest and greatest in research, a lot of it happening here at MIT. And then we'll close today's lecture with an overview of what's different, what's unique about machine learning healthcare. All of you have taken some machine learning course in the past, and so you know the basics of supervised prediction. Many of you have studied things like clustering, and you're certainly paying attention to the news where you see news every single day about Google, Facebook, Microsoft's latest advances in speech recognition, computer vision, and so on. So what's really different about trying to apply these techniques in the healthcare domain? The answer is that there's a huge amount of difference, and there are a lot of subtleties to doing machine learning right here. And we'll talk about that throughout the whole entire semester. So to begin, this isn't a new field. Artificial intelligence in medicine goes back to the 1970s or sometime even in the 60s. One of the earliest examples of trying to use artificial intelligence for diagnosis was this Mycin system developed at Stanford, where the goal was to try to identify bacteria that might cause infection, and then to try to guide what would be the appropriate therapy for that bacteria. Now, it was found that this algorithm, this machine learning, this simple AI algorithm, was able to propose a good therapy in 69% of cases, which at the time was better than the best or very good infectious disease experts. Now, it also had some other elements of it which were quite interesting. So those of you who've been following the latest in chatbots might find this little present. So there's a dialogue interface where the computer says, "I am ready." The computer, the clinician responds, "This is a 26-year-old male patient." The computer tests its understanding of what's going on. It says the age of the patient is 26, the sex of the patient is male.
Okay.
For internist one or quick medical reference. So this is try to reason about what's going on with the patient based on the data that's available for the patient, the symptoms. But the modern view of this shouldn't, of course, use binary indicators of each symptom, which have to be entered in manually, but rather all of these things should be automatically extracted, diagnose what's going on with them, deploying algorithms here. Health insurance agencies. Provides health insurance, so governmental ones, about as providers, but of course they're not just doctors, they're also nurses, and community health workers, and so on.
I will here stop it for a while, and to illustrate, explain that is machine learning transform every aspect of healthcare. From this paragraph, we see there is 3 aspects. One is the pair from government and employees and individuals, right? And another is provided for that is different, like is mechanics, that is hospital doctors, this field, and another is patient. And so we should account for that our data maybe comes from that patient symptoms, and to trans this data to that is provided, like a hospitals, doctors that give the analysis, their symptoms, that give that is a result or predict that the patients maybe have the disease, right? But on the other hand, we should below on that is the government guided, because you know we have insurance and sometimes insurance covered and have taxes. This inferred that is economical aspect. So on the other hand, that in this chain, that the government maybe can provide the funds and sometimes give that guide for the hospitals. Okay, maybe you will give that is loyal and that is schemers to improve the medical care that is like to development these areas. Okay, so this is machine learning. But as for academic areas, the professional experts always like to only focus on their research on these areas in these two aspect. Okay, and here let's to back for a little bit.
In 2015, AI, which is here in Boston, made a big difference. The ones that I would really like to point out because of their relevance to this course are learning with high-dimensional features. So this was really the advances in the early 2000s, for example, in support vector machines and learning with L1 regularization as it made medical imaging software and thus had accumulated a large amount of medical imaging data for $1 billion in 2015. They purchased Truven for $2.6 billion in 2016. Flatiron Health, which is a company in New York City focused on oncology, was purchased for almost $2 billion by Roche, a pharmaceutical company, just last year. And there's several more of these industry moves. And again, I'm just trying to get you thinking about what it really takes in this field, and access to data is actually a really important one, obviously. So let's now move on to some examples of how machine learning will transform healthcare. To begin with, I want to really lay out the landscape here and define some language. There are a number of different players when it comes to the healthcare space. There are us, patients, consumers. There are the doctors that we go to, which you could think about as providers, but of course, they're not just doctors. Veterans Health Administration runs one of the biggest health organizations in the United States, servicing our veterans from the department, people who retired from the Department of Defense, which has one of the second biggest health systems, the Defense Health Agency. And that is an organization where both of those organizations, where both the payer and the provider are really one. The Center for Medicare and Medicaid Services here in the US provides health insurance for all retirees in the United States, and also Medicaid, which is run at a state level, provides health insurance to a variety of individuals. We also have to think about industrial. Do you send them home? For each one of those things, what should the most immediate actions be? At least here in the US, we're always understaffed. So we've got limited resources and very critical decisions to make. So this is one example of a setting where algorithms that are running behind the scenes could potentially really help with some of the challenges I mentioned earlier. So for example, one can imagine an algorithm which builds on techniques like what I mentioned to you for internist 1 or quick medical reference, try to reason about what's going on with patients based on the data that's available for the patient, the symptoms. But the modern view of this shouldn't, of course, use binary indicators of each symptom, which have to be entered in manually, but rather all of these things should be automatically extracted from the electronic medical record or listed as necessary.
Okay, in this part, this professor provided that is a method that it means that we should from that electronic medical report and list as necessary. That electronic medical record, that is the formula for text, for context. Sometimes we should account for that we get that it like I think that like a sniffer, let a sniffer such as like this is a software. He can get that is many data from the website, and he can have the data set. Okay, and as for the electronic medical record, we should, based on the direction, our professional direction, such as this professional directions is only in that is medical areas. We use that is contact calculate method to compare this symbol to the directions and to get that is a coin idea, such as in one sentence, in paragraph, we can extract that is a coin, like context. So this is one method. And on the hand, such like this is diseases, we have different diseases in these areas because we are not professional experts, right? So if we are programmer, we must to contact with a doctor. Hi, professor, doctor, can you give me that is a direction, can give me some introductions about explanations about how this disease meanings, these terms with meanings. Like we collected these data into like a dictionaries. But you should pay attention. These dictionaries must be like to obey that is standards by some typical organizations. Okay, like so on some cases we make face a different name for the same disease. Yeah, different names. On this aspect, on this case, we should to build a like is typology or like is a schema to explain these different names have the same meanings. Okay, like XML, HTML, RDF. This method, okay? And here, continue.
And then if one could reason about what's going on with the patient, we wouldn't necessarily want to use it for diagnosis, although in some cases you might use it for earlier diagnosis. But it could also be used for a number of other more subtle interventions. For example, better triage to figure out which patients need to be seen first, early detection of adverse events, or recognition that there might be some unusual actions, which might actually be medical errors that you want to surface out and draw attention to. Now, you could also use this understanding of what's going on with the patient to change the way that clinicians interact with patient data. So for example, one can try to propagate best practices by surfacing clinical decision support, automatically triggering this clinical decision support for patients that you think it might be relevant for. And here's one example where it says, the ED dashboard, the emergency department dashboard, decision support algorithms have determined this patient may be eligible for the atrial cellulitis pathway. Cellulitis is often caused by infections. Please choose from one of the options. Enroll in the pathway, decline, and if you decline, you must include a comment for the reviewers. Now, if you clicked on enroll in the pathway, at that moment, machine learning disappears. Rather, there's a standardized process. It's an algorithm, but it's a deterministic algorithm for how patients with cellulitis should be properly managed, diagnosed, and treated. That algorithm comes from best practices, comes from clinicians coming together, analyzing past data.
Okay, in this part, you say that if we use the machine learning, we should depend on that is the professional guide, right? Because in different symptoms that we should depend on that is professional that is like it's to training we should to training that our accuracies to know about this accuracies. Oh, this patient have this disease, and maybe that he will what will that is a symptoms will becoming worse, or well, he will give that is determining predictions, right? Okay.
Understanding what would be good ways to treat patients of this type, and then formalizing that in a document. The challenge is that there might be hundreds or even thousands of these best practices. And in an academic medical center where you have patients coming, where you have medical students or residents who are very quickly rotating through the system, and thus may not be familiar with what are the most appropriate clinical guidelines to use for any one patient in this institution, or if you go to a rural site where the question of which one to use when is very challenging. And so that's where the reason about what's going on with the patient or trigger. And might be coming in for a psychiatric condition, which includes laboratory test results that are relevant. Both laboratory tests and interventions like aspirin that might be suggested. Now, these are also examples where these order sets are not created by machine learning algorithms, although that's something we could discuss later in the semester. Rather, they're standardized, but the goal of the machine learning algorithm is just to figure out which ones to show when directly to the clinicians. I'm showing you these examples to try to point out that diagnosis isn't the whole story. Thinking through what are the more subtle interventions we can do with machine learning and AI in healthcare is going to be really important to having the impact that it could have. So other examples, now a bit more in the diagnosis style, are reducing the need for specialist consults. So you might have a patient come in and it might be really quick to get the patient in front of an x-ray to do a chest x-ray, but then finding the radiologist to review that x-ray could take a lot of time. And in some places, radiologist consults could take days, depending on the urgency of the condition. So this is an area where data is quite standardized. In fact, MIT just released last week a data set of 300,000 chest x-rays with associated labels on them. And one could try to ask the question of, could we build machine learning algorithms using the convolutional neural network type techniques that we've try to understand what's going on with this patient. For example, in this case, of data that are available to all. We into what it takes you out techniques from the 80s, 90s. Look at the distance between peaks. because of the large wealth of data that's available, we've been using convolutional neural network-based approaches to try to understand this data and predict from it. Yet another example from the the chief complaint is it's usually a very short 2 or 3 word rectal pain, right upper quadrant, RUQ, abdominal pain. And it's just a very quick summary of why did the patient come into the ER today. And despite the fact that it's so few words, it plays a huge role in the care of patient. If you look at the big where if complaints are used for it's used for patients in particular time. But the data that has and it was something to static drop down over here would have killed it.
Give the attribute of these symptoms and give that is classified these symptoms to build that is learning models. And for maybe you use several rounds like training, you will give that is standards that is correct a prediction about the symptoms in this patient or in this patient. So like this is a method. Okay, continue. We will over 15 minutes.
Quite a bit of information in that. We take that, we use a machine learning algorithm, a supervised machine learning algorithm in this case, to predict a set of chief complaints now drawn from a standardized ontology. We show the 5 most likely ones, and the clinician, in this case the nurse, could just click one of them and it would enter it into there. We also allow the nurse to type in part of a chief complaint, but rather than just doing a text matching to find words that match what's being typed in, we do a contextual autocomplete. So we use our predictions to prioritize what's the most likely chief complaint that contains that sequence of characters. And that way, it's way faster to enter in the relevant information. And what we found is that over time, we got much higher quality data out. And again, this is something we'll be talking about in one of our lectures in this course. So I just gave you an example, a few examples of how machine learning and artificial intelligence will transform the provider space. But now I want to jump up a level and think through not how do we treat a patient today, but how do we think about the progression of a patient's chronic disease over a period of years? It could be 10 years, 20 years. And this question of how do we manage chronic disease is something which affects all aspects of the healthcare ecosystem. It'll be used by providers, payers, and also by patients themselves. So consider a patient with chronic kidney disease. Chronic kidney disease, it typically only gets worse. So you might start with a patient being healthy and then have some increased risk. Eventually they have some kidney damage. Over time, they reach kidney failure, and once they reach kidney failure, typically they need dialysis or a kidney transplant. But understanding when each of these things is going to happen for patients is actually really, really challenging. Right now, we have one way of trying to stage patients. A standard approach is known as the eGFR. It's derived predominantly from the patient's creatinine, which is a blood test result, and their age. And it gives you a number out. And from that number, you can get some sense of where the patient is in this trajectory. But it's really coarse-grained and is not at all predictive about when the patient is going to progress to the next stage of the disease. Now, other conditions, for example, some cancers, like I'll tell you about next, don't follow that linear trajectory. Rather, patients' conditions and the disease burden, which is what I'm showing in the y-axis here, might get worse, better, worse again, better again, worse again, and so on. And of course, it's a function of the treatment for the patient and other things that are going on with them. Understanding what influences how a patient's disease is going to progress and when is that progression going to happen could be enormously valuable for many of those different parts of the healthcare ecosystem. So one concrete example of how that type of prediction could be used would be in a type of precision medicine. So returning back to the example that I mentioned in the very beginning of today's lecture of multiple myeloma, which I said my mother died of, there are a large number of existing treatments for multiple myeloma. And we don't really know which treatments work best for whom. But imagine a day where we have algorithms that could take what you know about the patient at one point in time. That might include, for example, blood test results. It might include RNA-seq, which gives you some sense of the gene expression for the patient. That, in this case, it would be derived from a sample taken from the patient's bone marrow. You could take that data and try to predict what would happen to a patient under two different scenarios. The blue scenario that I'm showing you here, if you give them treatment A, or this red scenario here, where you give them treatment B. And of course, treatment A and treatment B aren't just one-time treatments, but they're strategies. So they're repeated treatments across time with some intervals in them. And if your algorithm says that under treatment B, this is what's going to happen, then the clinician might think, okay, treatment B is probably the way to go here. It's going to long-term control the patient's disease burden the best. This is an example of a causal question, because we want to know, how do we cause a change in the patient's disease trajectory? And we can try to answer this now using data. So for example, one of the data sets that's available for you to use in your course projects is from the Multiple Myeloma Research Foundation. It's an example of a disease registry, just like the disease registry I talked to you about earlier for rheumatoid arthritis. And it follows about 1,000 patients across time, patients who have multiple myeloma, what treatments they're getting, what their symptoms are, and at a couple of different stages, very detailed biological data about their cancer, in this case, from RNA-seq. And one could attempt to use that data to learn models to make predictions like this. But such predictions are fraught with errors. And one of the things that Pete and I will be teaching you in this course is that there's a very big difference between prediction and prediction for the purpose of making causal statements. And the way that you interpret the data that you have when your goal is to do treatment suggestion or optimization is going to be very, very different from what you were taught in the introductory machine learning algorithms class. So other ways that we could try to treat and manage patients with chronic disease include early diagnosis, for example, of patients with Alzheimer's disease. There's been some really interesting results just in the last few years here. Or new modalities altogether, for example, liquid biopsies that are able to do early diagnosis of cancer, even without having to do a biopsy of the cancer tumor itself. Challenging control problem there. If you give the patient too much insulin, you could kill them. If you give them too little insulin, you could really hurt them. And how much insulin you give them is going to be a function of their activity, it's going to be a function of what food they're eating, and various other factors. So this is a question which the control theory community has been thinking through for a number of years, and there are a number of sophisticated algorithms that are present in today's products, and I wouldn't be surprised if one or two people in the room today have one of these. But it also presents a really interesting opportunity for machine learning, because right now we're not doing a very good job at predicting future glucose levels, which is essential for figuring out how to regulate insulin. And if we had algorithms that could, for example, take a patient's phone, take a picture of the food that a patient is eating, have that automatically feed into an algorithm that predicts its caloric content and how quickly that'll be processed by the body, and then as a result of that, think about when, based on this patient's metabolic system, when should you start increasing insulin levels and by how much? That could have a huge impact on quality of life for these types of patients. So finally, we've talked a lot about how do we manage healthcare, but equally important is about discovery. So the same data that we could use to try to change the way that algorithms are implemented could be used to think through what would be new treatments and make new discoveries about disease subtypes. So at one point later in the semester, we'll be talking about disease progression modeling, and we'll talk about how to use data-driven approaches to discover different subtypes of disease. And on the left here, I'm showing an example of a really nice study from back in 2008 that used a k-means clustering algorithm to start increasing insulin levels, and by how much. That could have a huge...
Okay, that I will share this course, the website link with you, and you have time that you can to continue. So from these videos, we know about the procedures of how to use machine learning to analysis that is data comes from that medical care, these areas. So such in this part, we know about that. Depending on the different algorithms, we must to give the signal process, and that is a data process. At last, we should give that is a correct models to attribute that is a symptoms attribute. At last, we should combine with the professional that they'll such as record and to give the predictions, professional predictions, and to give the trend of that patient's diseases. So I think it's very interesting in that is Internet of Things, right? But as for every one of us, in the future, we have the opportunity to contact that these technologies, these areas. But I think, from my point of view, wellness that the technologies advance. As for us, for technique, I think technique engineer, and for customers, for users, we should admire the technology, right? But on the other hand, we should keep on studying, keep on tracking. That is the development of the technologies, and use them to solve the realistic problems based on our life. This is the idea, this is the core idea of this course, all right? So that's all for today. Okay, everyone. Before we over our class, I will make advertisement. Advertisement. Let's check that our schedule, right? So next week is 17. Yeah, 17. Next Thursday, 17. Please, these 4 students, please be ready your presentation. Okay. The number I check is 529 30 05. Okay. Please be ready your presentation. Before you attend that is next class, please set your point to me, to my mailbox. My mailbox, please check on WeChat. Okay? Yeah. Good. If you have, yeah, please.
Okay, how long should our PowerPoint be? Maybe how many pages?
Not short, not less than, I think that is 20 minutes.
20 minutes. Okay. How many pages? Like, which page?
It's okay. No, ask for that how many pages. Only for your content, your explanations, your presentations. Okay. Yeah. Have a good day, everyone.
Have a good day. Thank you.
Bye. See you next Wednesday. Thursday, right?
Yeah.
Bye. See you. Hi, I leave my voice message to you. So you know that you have not that devices of RFID, right? So I suggest you can check some like applications introductions online and to get some information about how to choose that is devices, the types of devices, and to give that is a log, that's a log, and you can check that some books or some papers online. There maybe have some information can provide it to you. You not realize that your systems. Hi, I leave my voice message to you. So you know that you have not that the devices of RFID, right? So I suggest you can check some like applications introductions online and to get some information about how to to choose that is devices, the types of them. I summarized my meaning. I summarized that in your experiment report, you can first introduce some back technologies about RFID, this part. And second, you can introduce that when you designed a log, RFID log, what should you do? Yeah, such as like the type that RFID and how to design that is the blackboard. I mean, in your experiment report, you can first write something about these technologies to introduce these technologies in the first part. The second, you can introduce how when you designed this is a log, what will you do? First, you will choose that device, right? And the second will design maybe the mainboard. And the third, maybe when you to connect this device together, how to deal that informations, right? You can give only that is a flow and in structure, okay? You should not to realize this log only to introduce the method is okay.
Thế là rồi giá trị cả đầu tư tới đó lên trong tiền giấy đang được